Now we bring the architecture into the real world. A regulated fabric network needs more than smart contracts. It needs decisions, controls, privacy, audits, and risk management that show the network is trustworthy, compliant, and ready for production. You've built the foundation: fabric mechanics, application development, deployment, operations, and governance concepts. Now we apply that full path to the production layer, where compliance, privacy, auditability, and risk controls become part of the network design. Governance should be designed into the network, not added as paperwork after launch. Consortium agreements must translate into who can join, who can endorse, what data stays private, how changes are approved, and what evidence auditors can inspect. Fabric provides enforcement tools such as MSPs, policies, channels, endorsement rules, and private data collections. The architecture task is to connect each business obligation to a technical control and an operational proof. A regulated consortium works only when decision rights are explicit. Members may run peers, provide applications, audit activity, or represent regulators, but they should not all have the same authority. Governance bodies turn those roles into decisions: who joins a channel, who approves chaincode, who changes infrastructure, and who leads incident response. The key principle is separation. Business governance sets policy and risk appetite, while operations executes under those approved rules. Before production, governance has to become operational, not just aspirational. Each decision type needs a defined approval model: simple majority for routine actions, supermajority or unanimity for higher risk changes, and weighted voting when members do not have equal stakes. Emergencies need the same discipline, even when speed matters. Every onboarding decision, MSP update, channel change, and policy revision should produce signed evidence that auditors can verify later. Participant lifecycle management should be treated as a controlled governance process, not an informal network task. A new organization must pass legal review, due diligence, security checks, identity provisioning, and connectivity validation before becoming active. In Fabric, that means updating MSP configuration, issuing certificates, setting channel access, and confirming operations. Exit requires the same discipline: revoke certificates, remove access, manage channel participation, preserve audit evidence, and document each change through approved tickets and signed configuration records. Chaincode governance treats smart contracts as controlled business assets. A proposal should trigger design review, code review, security testing, and compliance impact analysis before deployment. In Fabric, organization approvals connect the technical lifecycle to consortium decision rights. After commit, teams still need to monitor behavior, preserve evidence, and manage versioning, rollback, emergency patches, upgrades, and deprecation. The goal is controlled change. Every contract version is justified, tested, approved, traceable, and reversible. When a supplier challenges a shipment status recorded by a logistics provider, the network should not improvise. The dispute is classified, then raised through operational support. If it cannot be settled there, it escalates to the governance committee or arbitration. Investigation relies on shared evidence: ledger transactions, private data hashes, event logs, access logs, and signed approvals. The outcome should include remediation, corrective action, and a governance record, so accountability survives beyond the individual dispute. Compliance mapping connects what regulators require to what the Fabric network actually enforces. Start by identifying obligations such as privacy, reporting, traceability, standards, and contracts. Then map each one to concrete controls: identity, access, encryption, logging, retention, monitoring, and approvals. Finally, define the evidence sources, such as ledger history, configuration changes, CI/CD records, and audit reports. The goal is traceability. Every requirement has an owner, an implementation, and proof. Auditability in Fabric starts with the ledger, but it does not end there. Transaction history provides traceability and non-repudiation, while operational records explain how the network was configured, accessed, deployed, and monitored. These sources should be retained in an evidence repository and tied to repeatable audit procedures: reviews, exception handling, control testing, and regulator requests. Reporting then translates the evidence into accurate, privacy-aware outputs for each audience. Residency and retention are governance decisions, not just storage settings. In Fabric, you must know which jurisdictions can hold ledger data, private data, logs, certificates, backups, and archives. Retention rules define what stays, what expires, and what can be purged. But deletion must still preserve required hashes and audit references. Legal hold overrides normal cleanup. If an investigation begins, relevant records, including backups and logs, must be protected immediately so compliance remains defensible. Privacy in Fabric is not a single setting. It is a layered design decision. Start by minimizing what goes on-chain and keep highly sensitive details off-chain when possible. Then restrict visibility with private data collections, separate channels, and application authorization. Add encryption, consent, purpose limits, and pseudonymization where policy requires them. Finally, make reporting privacy-aware, so dashboards and analytics reveal useful patterns without exposing personal, commercial, or regulated data. As Fabric data moves into analytics and AI, the risk profile changes. The issue is not only who can see a transaction, but what a model can infer from patterns across many transactions. Governance should begin with approved use cases, clear access limits, and documented purposes. Then add privacy-preserving techniques such as aggregation, masking, differential privacy, or secure enclaves. Treat models as governed assets by tracking dataset lineage, approvals, monitoring, misuse signals, and drift over time. A production readiness review is the final governance gate before launch. It brings every readiness question into one decision. Can this network be safely operated, audited, supported, and defended? Business teams confirm agreements, SLAs, support, and escalation. Technical teams prove performance, resilience, monitoring, backups, and chain code approvals. Compliance and risk owners verify evidence, privacy, retention, incident response, and accepted residual risk. If any blocker remains, the decision is no-go until it is resolved. Governance, compliance, privacy, and production readiness turn a Fabric design into a trusted consortium network. The goal is not just working transactions, but accountable decisions, auditable controls, protected data, and sustainable operations. Next, we bring these pieces together in the capstone by designing an end-to-end Fabric solution.